Welcome back. In this video, we are going to solve problem 13-11 that is taken from chapter number 13, Buckling of Columns, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. So statement is the A992 steel angle has a cross-sectional area is shown and a radius of gyration about x-axis is 1.26 inch and about y-axis it is 0.879 inch. The smallest radius of gyration occurs about AA axis and is 0.644 inch. If the angle is to be used as pin connected 10 feet long column, determine the largest axial load that can be applied through its center without causing it to buckle. So this is an angle which is A992. The radius of gyration about x-axis is given, y axis is given, and the smallest radius of gyration occur about section AA, and you have to find the largest axial load that can be applied. So let's start with the solution. As we know that using Euler formula, critical stress is equal to critical load divided by area. So we know that critical load is equal to pi square EI divided by LE square, where L is effective length and A is also there. Also, we know that we have this moment of inertia that is equal to area multiplied by radius of gyration square. So from here, what we will do is that we will get this critical stress is equal to pi square E, and instead of I we will write A multiplied by R square divided by area multiplied by effective length square. Okay, so A will cancel, so we will get critical stress will be equal to pi square E into R square divided by LE square. So now what we will do is that if you divide numerator and denominator by R square, so you will get pi square E and R square divided by R square divided by LE square over R square. So this will cancel each other. This R square and R square in numerator will cancel. So we will get critical stress will be equal to pi square E divided by LE square over R square, which can also be written as pi square E divided by LE over R whole square. Now we know that effective length is equal to K multiplied by L. So what we'll get is critical stress is equal to pi square E divided by KL over R whole square. Now this term L over R is equal to slenderness ratio, and you can see that if this value is high, so your critical stress will be low. So what we will do is that for this, if you take, let me write it, take minimum radius of gyration. So what will happen that this term will be having higher value. So in that critical stress will decrease. So what is minimum radius of gyration? That is RA, and RA is given as 0.644 inch. So RA is 0.644 inch. Okay, now what is K? So both ends are pin connected, that is pin connected, and we have seen that for pin connected, if I go to the book, so let me show you here that this is pin ends. So K is equal to 1 for pin ends. So K is equal to 1. Also, what is length? So length is given as how much? 10 feet. So 10 feet, and we know that 1 feet is equal to 12 inch. So 10 multiplied by 12 and it will be equal to inch. And what is the modulus of elasticity E and the yield stress? So we will check it from the book A992. Steel is given. So again, you have to go to the end of this book, average mechanical property, and you will check that again it is also, this is the value of E into 10 raised to power 9 ksi, and this is 50 ksi yield stress. So I will write it, E is 29 into 10 raised to power 3 ksi, and that is 50 ksi. Now you have each and every value, just plug it in this formula. So you will get critical stress is equal to pi square multiplied by 29 into 10 raised to power 3 divide by this K is 1 multiplied by L is 120 inch. So 120 divided by radius of gyration, which is 0.644, and its whole square. So we will calculate that pi square 3.1417 square multiplied by 29 into 10 raised to power 3 is equal to 286,238.087 divided by this term, which is 120 divided by 0.644 and answer square. So that is 34720.882. Now we will divide 286,238.087 divided by the answer will give you critical stress, and that will be equal to 8.243 ksi. Also, Euler formula is valid when you know that critical stress is less than yield stress. So critical stress is 8.243 ksi, and that is less than sigma yield is 50 ksi. So it means that we can find the maximum load, and we know that critical load will be equal to critical stress multiplied by the area. So 8.243 multiplied by area is given as 2.48. So 2.48, and we will get critical load that will not produce any buckling. This is the maximum load which can be applied. So you can see that is 20.4 kips. So 20.4 kips. So this is the maximum allowable load that can be applied to this A992 angle column, that is 10 feet length, having pin connected, and that can be support this load without buckling. So this was all about problem 13-11. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.